Hello and welcome back to Calculus 3. This is exam 1 review because in your infinite wisdom you picked to have the test next class, so fine, I'll bring. The test should have about 10 questions. We are looking into chapter 11. Here, I'll write this in blood. Review chapter 10. Because, guys, parametrization is in chapter 10, right? And basic polar stuff, chapter 10. We're going to use polar coordinates, obviously, much more in chapter 13 and 14, but, you know, some basic stuff from 10.2 can pop in. And obviously, when we talked about the vector valued function, R, that's just a set of parametric equations, which is, we talked about having a circle written as x squared plus y squared equals to let's say 9. Then we also said, but you can write it as a parametric set of 3 cosine theta or t, and then y equal 3 sine theta. So that was another way. And then finally, chapter 11 way, r of t equals to 3 cosine t, 3 sine t, right? So, yeah, parametric equations in chapter 11. So that's 10.1. If you need to see lectures on that, I do have them on my channel, the way I teach them in Calc 2. So just go into, once you are on my channel, just hit that search button and type in 10.1. That's all you need to do. It will give you 4 or 5 videos on parametric equations. If you have issues, obviously if you don't have issues, just don't worry about it. So what is on the test? Chapter 11. Chapter 10 is prerequisite. In the light of past events, you better be able to differentiate and integrate e to the x, otherwise you're not going to have a good time right on the test. We are looking into vectors in 2D and 3D, so R2 and R3. And we are when we say vectors, we are saying addition, subtraction, scaling times a constant, then how to get the vector when you subtract points, also angle between two vectors, right, with a dot product, and then for R3 cross product. So let's go number 2, the dot product, and then that dot product is going to have the angle between vector u and vector v. And then number 3, cross product, and that cross product is going to be looking for the normal vector. Now, yes, we use the normal vector in chapter 12 to get the plane, but you learn how to find the cross product in chapter 11. I have to single out, this is not a lecture on its own, but I have to single it out because the projection problem, generally, that's, you know, under the veil of dot product, that it's in that lecture, but I put it as a special topic. So, all right, so then we have a vector valued function. And that's your R of t, which is a set of parametric equations. And we learned how to describe lines in space, right? So line and curves in space in R3. So that's what the vector valued functions are for. This is where we talked about the helix, right? And then is the helix wrapping around x, y, or z axis, and how fast the helix is rising, and which orientation we have, is it clockwise, counterclockwise. So all of that stuff, right, was in here. Slinky versus sphere, and all of those things. That was all in number 5. And the number 6, calculus, right? So to be able to take the limit, derivative, and integral, and this is where you do term-wise, right? You have 3 components in vector R, you differentiate each one separately, or you take the limit each one separately. A limit might be the L'Hopital rule, 4.8 from your calculus 1. So number 6. I spelled it with C's, I'm sorry. So calculus of vector valued functions. Then we have number 7. So the next one should be motion in space, but I kind of keep that as the last resort. You are supposed to, when we say motion in space, that's technically application of this, because to get from r to velocity to acceleration, you will be differentiating, and to go backwards you are integrating. So singling out motion in space is somehow not fair, right? Because it is the calculus of vector valued functions. So if I give you a velocity vector and I'm asking for position, just because you know concepts from Calc 1, oh, velocity, need position, integrate. Or velocity, need acceleration, oh, differentiate, right? So no matter where you are in the hierarchy, right? If you differentiate, you will go this way. If you integrate, you are going backwards. So we derived our equation for all of the physics equations by integrating gravity. You remember? And that is in your notes. So we started by specifying, there it is, that the acceleration is negative g, and we just integrate to develop the formula for physics, right? Now in physics, your professor tells you memorize this formula. Well, in Calculus 3 now you know where this formula is coming from. So the honors students, you should know this derivation, because this is calculation from Calculus 3 and differential equations, right? Separation of variables. And the lighter version for everyone in a class is the beginning of the story here, where you have your path function given, you take the derivative to come up with the velocity function, you take another derivative to get acceleration function, and then you get the speed off of the velocity when you do the magnitude. Everyone in the classroom must know this, because this is the bare minimum for application for calculus in general. So that's the motion in space, and just taking derivatives and integrals, which is technically number 6. Number 8, length of curves. And you have 3. Calculus 2 formula is included in this list. So you have the Calculus 2 formula, where L was a to b square root of 1 plus f prime squared dx. And then you have the parametric one, which is the one that we did in honors. Needs to know the derivation, how to switch from one to another. So this was x prime squared plus y prime squared dt. And finally the polar, which is why I asked you to look into basic polar 10.2 and 10.3 from Calc2, because now you have a polar version with the f squared plus f prime squared d theta as length of curves. So either one of these could be there. There has to be a problem on it. It's just the question is which one of the three. And for the honors, in addition, you have a derivation for any of the two below. Generally, because the one on the bottom takes forever, you know, so less probability, but still. And then we get our curvature. And finally, our carpal tunnel section on carpal tunnel development section on normal principal unit normal vector. Remember how you asked that really nice problem of TT squared and it took an hour? Yeah. So try to find something civil that is not going to take an hour to go through, but this should be definitely the last problem you do on the test, because it takes forever, right? You need r prime, and then you need the t, then you need t prime, then you need the t magnitude, t prime magnitude, right, to come up with the last thing. So normal, principal unit normal vector. Test taking skills. You read the entire exam first, and then you work on the problems that you can do like this, right? And then you go back and you look at problems like this, and definitely principal unit normal vector, curvature, those things should be last because they take the longest to do. And some quick stuff, maybe you have to add vectors or scale vectors, do the cross product and angle between two vectors, right? Stuff that you can do with a single formula and maybe 2 or 3 lines of calculations. You should do that first, and then leave the one-page calculations for curvature and normal vector to be done last. The idea is to have about half of your exam done in first 15 to 20 minutes. If you are prepared for the exam, you will be able to do half or even more than half of the exam in the first 15 to 20 minutes of the test. I do have students that leave Calc3 exams at the 40-45 minute mark, but they're very prepared, and pretty much all of them have all 7 quizzes done, and they did the sample test I talked about long time ago. So they identified their issues and problems, and they fixed them since. It is not late for you to do that post-test. Remember that your MyMathLab, underneath where your quizzes are, if you scroll down, you are going to run into a Chapter 11 post-test. Chapter 11 post-test is the sample exam that MyMathLab is going to grade when you are done, and it will show you exactly which areas you're not good at. You should try that exam today, because you still have 5 days till the test. If you do that test today, you will have 4 days to fix the problems that that test identifies. Just make sure when you're doing this test as a practice, it's called a post-test. There is also a pre-test. That is not the one you want, because that's the prerequisites for the knowledge. You need the post-test. The post-test will identify exactly your issues. Just make sure you're not using formulas and things as you are doing that test. You want to test your knowledge. I don't get that grade on my end, so don't worry about it. You can score 12. I'm not going to know. All right. Whatever you score, hopefully you're not scoring 12 5 days before the test, but you can score whatever you score. It's just important for you to identify the areas you have to fix. Questions, concerns? Yes?
Do you want us for the test, would you want us to make any graphs of any kind for the test?
Well, if you are graphing, you are definitely going to graph something that you have seen before. So it's going to be, we covered very few graphs. So helix is one of them, for instance, right? This section that we just covered is not on the test, so you don't have to worry about these 3D shapes. But these 3D shapes would be on the next test, right? So the idea is to look into the basic graphing of a point or a line in space, because you graph 2 points and you stretch a line through that, right? A helix. So some of that simple stuff that we did. We didn't do really almost any graphing. So that's very. You guys need to know all of the formulas. So study formulas, because that's your Calc 3. You saw that all of the calculations are Calc 1 basic stuff, right? Apart that one integral, right? Other than that, everything is like a very basic Calculus 1 calculation. You knowing Calc 3 means knowing concepts and formulas from Calc 3. So that's what you're learning, and that you will display on Wednesday if you show up. I hope you will. Remember that not even the handwritten note from God will excuse you from the test, because we are not on good terms. Yeah. We don't like each other. Exactly. Mortal enemies. Any other questions, concerns? Yeah.
Please reopen the homework.
Who's asking?
I second that motion.
There we go. See. So you guys know about the study plan, right? So sure.
Oh yeah, it's the same thing.
Study plan is better actually, because study plan has everything. Homework has just some examples that are pulled from study plan. So if you're asking because there is a 0 on the homework, that's a different than, oh, I want to study. Because if you want to study, you can pull the study plan and go into chapter 3, right? And learn differentiation in Calc 1. That's how powerful study plan is. So, all right, well, I'm fine. Anything else? Okay, the door is right there. See you Wednesday.